The course that I will be teaching this semester and would like to present today is titled Real-Time Cities. Real-time cities deploy novel technologies to merge urbanity with digital information so that the built environment is dynamically sensed and synchronously actuated to perform more efficiently, intelligently, and sustainably. To examine the real-time city, we will borrow from the sensationalist approach of Etienne Bonneau-Doucaudiac, who offers an interesting meditation on sensibility as the source of subjectivity. He imagines a living statue devoid of any sense but smell. He walks the reader through a sequence where olfactory sensation leads to comparison, which leads to judgment, which leads to reflection and reasoning, which leads to abstraction, and the sum of all the above results in what can be characterized as understanding and human agency. This sensationalist approach can be applied to cities. Once populated with a large number of sensors and endowed with the capacity to register changes in its context, a city can acquire a limited level of agency through comparison, judgment, reflection, reasoning, and abstraction. The sentient city agenda happens at the intersection of urban informatics and information aesthetics, where form follows data. Three core methodologies of urban sensing are salient to this agenda: viral sensing, sensor networks, and crowd sensing. In viral sensing, we can leverage existing systems that have been developed for other reasons, but can function as sources of information on how our cities operate. The premise of this sensing practice is that the contemporary subject involuntarily leaves digital traces on various networks that are juxtaposed over urban areas. Every time a credit card is used, a text message or an email is sent, a Google query is submitted, a phone call is made, or a purchase is processed on a major online store like Amazon.com, an entry with the time and location of this action is added to a data set on a central server, which is administered and maintained by the organizational entity providing the platform for these day-to-day operations. These data sets, if spatially and temporally cross-associated, become invaluable sources of information about the dynamics of the city based on which the city can be actuated. For example, the real-time visualization of data mined from communication networks can be cross-referenced with the geographical terrain to reveal urban dynamics in real time to observers. Aside from tapping into existing networks, customized sensor networks can also be implemented. This allows to extract large amounts of information about the processes contained within the built environment. A great example of such a scenario is the digitally enhanced tags that could be attached to objects and could report their location to an internet backbone infrastructure via a cellular network and channel this to a central control and command mechanism. Instead of a top-down approach like implementing sensor networks, we should also consider more grassroots bottom-up systems for sensing the dynamics of cities. One possibility is thinking of each urbanite as a human sensor, an agent for sensing and reporting his or her individual experience by tapping into data which is generated by user-contributed content on content-sharing platforms. Hence, we arrive at the third possibility of urban sensing, which is crowd sensing. Why is it important to be able to sense the dynamics of the city? This allows us to consider the application of operating mechanisms at an urban scale and actuate the city in real time based on what is sensed about its dynamics. In terms of actuation, we can leverage various techniques to transform urban spaces to responsive, context-aware environments. These are environments whose inhabitants are incorporated as entities with transient preferences and needs. Instead of generic occupants, they become hyper-individualized users whose desires are taken into account by the cybernetic mechanisms that regulate the performance of the city in real time. Yet, manipulating a space through embedded actuators is not the only possible means of spatially regulating urban systems. The inhabitants themselves can be considered possible agents of regulation. In this regard, once access to real-time information about how the city operates is democratized, then citizens can be actuated and their actions can be self-regulated based on real-time knowledge conveyed on information delivery platforms. This offers them more control over their environment by allowing them to make well-informed decisions about their surrounding, reducing the inefficiencies of contemporary urban systems. Implementing prototypical urban cybernetic mechanisms that sense or actuate the city in any of the above-mentioned categorical variations promises the emergence of a smart city that is a desirable, safe, and sustainable place in which to live and work. The importance of such a prospect is that it is made smart by the collaborative activity of its citizens, who can function as sentient, self-reporting agents that contribute to monitoring the city as a dynamic organism. And at the same time, they are actuated based on the real-time knowledge of the dynamics of the city. Hence, the real-time city will function as an intelligent medium through which citizens communicate among themselves, transforming them from passive inhabitants to active participants in or actuators of spatial scenarios. While you're looking at some of the prototypical implementations of urban cybernetic mechanisms done by graduate students here at GSD, I would like to end this presentation with some logistics. The class meets every week for 3 hours from 2 to 5 on Fridays. Two open source programming and prototyping platforms called Processing and Arduino respectively are covered as technical tools for the design and small-scale implementation of projects in the above-mentioned categories. There will be a technology bootcamp to provide students with the basic knowledge of these platforms. In terms of course requirements, there will be weekly work-in-progress assignments, starting with an analysis of already implemented projects. We will then ease our way into preparing design briefs and developing design proposals, a necessary step in securing funding for projects. Finally, moving towards the implementation phase, where students cover the required steps for completing their individual prototypes of urban-scale cybernetic mechanisms. The course has a very hands-on approach towards the subject matter. And the goal is to have a set of very well-developed proposals and working prototypes by the end of the semester, which will hopefully allow students to apply for various exhibition venues and funding opportunities for their projects. Thank you, and I hope to see some of you in our first session of the class on Friday.